Hello? Okay, now it works. Sorry about that. You probably didn't hear anything, maybe? I'm not sure. I just noticed that my levels were low on the mic there. Or non-existent. Okay, let's restart. So, 0.16 has released, and I wanted to check it out a little bit. So what I wanted to do is to first install it, which we've done. So I used ZVM. I had to use like ZVM upgrade to upgrade to the latest one. ZVM is a Zig version manager, so you can use it to install different versions of Zig. And we upgraded it. You can type zvm list -- all to get all the available versions, and then to install 0.16 you would do install 0.16.0, and that is already installed for me, but then also ZLS to get the ZLS as well. So now we have both Zig and ZLS at 0.16. Hello, Ian. No, I'm looking at Zig 0.16 right now. So now we got that, and then I want to try just without looking at the notes. I will look at the release notes after, but I just wanted to see how easy it is to go into this. Let's see what they have. I think they have, maybe they have changed things here, but they're still using like debug print. What is this? Init. This feels new. Standard set of pre-initialized useful APIs for programs to take advantage of. This is type of the first parameter of the main function. Applications wanting more flexibility can add except init minimal instead. Okay. So we got an arena. Interesting. An allocator, GPA allocator as well. Oh, so you don't have to like okay, so these are apparently so common that they just added these. That's really cool. Can you be louder? I'm not sure, man. I think I have it on like very. Let's see. Hang on. One second here. Sorry. Volume, input volume. Okay, let's try and increase that. Okay, is that good? Is that better? Testing. Yeah, we'll try here. All right. So how long stream today? I don't really know. We'll see. Probably not that super long like yesterday, but probably like, I don't know, a couple of hours maybe. Like 2, 3. Okay, it's too loud. Well, let's lower it down a little bit. Okay, how is it now? It's better. Okay, cool. And you haven't adjusted your volume, because I basically never touch those controls. But I mean, something might have changed on my end, to be honest. Like I don't know. Anyway, okay, so because the levels, the level in OBS are like at the there's like the green bar, which reaches up to like, I don't know, 70-60%, and then you get like the yellow bar, and then like a red bar on top. And I never it feels like you don't want to go up in the red area. I don't know, but yeah. Anyway, thank you for telling me. Okay, so cool. So it looks like you can use this as a way to, and we also get the I/O here. I don't know what pre-opens is. Environment map, allocator, GPA allocator, and arena allocator. Strange that it's a pointer. Maybe that's because arenas are not copyable. I don't know actually. I thought they were, but. And minimal. I'm not sure what minimal is. Alternative to int as the first parameter of the main function, environment variables and arguments. Okay. So you can get like arguments here. Okay, cool. So they're showing how to access the arguments. So we basically have this args thing to slice. You give the arena. Apparently you have to give the arena for some reason. Does it have to be the arena that you get from the... Okay. Here it says return value may reference several allocations and may point into A. Therefore an arena style allocator must be used. So they're saying that whatever you get back from this might point back into A. Okay. Right. But as, I mean, yeah, as long as you use it, I guess, correctly, it should be fine. Okay, so they're just going through all the arguments. This is a string, I guess, yeah. Zero terminator string, even. Okay. All right. And okay, I see. This is the arena. This is an allocator from the arena. I see. It's not the arena itself. In order to do IO operations, we need an IO instance, right? So we simply grab this IO, and it seems to be copyable. It seems to work the same as the kind of allocator instance, where you can copy it around, which is nice. So I guess they have kind of the same idea here. vtable, user data. Oh, it's optional. Interesting. I don't think the allocator had optional pointer here. It just had the pointer. Okay. Okay, and then yeah, in order to do I/O operations within an I/O instance, standard out is for the actual output of your application. For example, if you're implementing gzip, then only the compressed bytes should be sent to standard out, not any debugging messages. Standard out buffer. Right, so we have the buffer, we have the file writer as usual, but now oh, I see, they are aliasing I/O. I usually just use the full name here. Okay, so I/O file writer init, and now okay, so you do like this now. So you don't have to go through the file, the standard out file, to create the writer anymore. I think maybe this is like a convenience function or something for that. Or okay, so you provide the file here, which is just .standard out. So that's actually really nice. They're utilizing the implicit field or declaration access. Hey RZ, thank you. Good to know. Okay, so you can just provide a file like that. So that looks pretty cool. And then you just provide the I/O instance like an allocator, except this is I/O. And the buffer. So that's pretty cool. And yeah, so talked about yesterday about the usage of these I/O, like this I/O interface. Like when you pass, in contrast to like passing the allocator around, like you're passing an allocator in, you know that there's probably gonna be like there's going to be side effects of creating memory or freeing memory or something like that. So that is very visible. The same would be now for the I/O interface, where if you pass an I/O in, you would know that there is going to be some kind of side effect with the I/O, like writing a file, deleting a file, or I don't know, something to do with I/O. So that is actually pretty good. That makes it very visible, and also it makes it. Yeah, I mean, I guess it's sort of easier also to see like what functions do not have those kinds of side effects. And I was talking also about maybe they can go all the way. They're probably not gonna do that, but it's easier to see like maybe if you have like pure functions, you know, real pure functions, you would not modify any state, but yeah, that's a whole nother can of worm. But anyway, they're probably not gonna do that because it's not supposed to be a functional programming language. It's not supposed to be Haskell. It's supposed to be Zig. But anyway, so we got the standard out file writer, and then we got the writer. So this is business as usual here. And then we have the writer that we can use to print things into. I guess one thing that you don't really see is like, okay, well, we have a writer. It's not 100% sure that it's going to have, you know, I/O side effects, because you could write into a memory buffer string as well. So I guess in that case, in that sense, it's not really visible. But anyway, print another message. This simply takes a writer and prints out a string. So this is an example of how you would use this writer interface, and this is the same as before. And we get the writer error there as well. Yeah. Okay, and then we flush as well. Okay, cool. So so the changes here basically is that we now take an init that I've never seen before, like an init parameter to the main function, which holds a bunch of useful things. The arguments in minimal, you have the arena allocator ready to be used, the GPA ready to be used, the I/O ready to be used, environment map, and pre-opens, which I don't really understand what it is. Let's look at what is this. Named files that have been provided by the parent process. This is mainly useful on WASI, but can be used on other systems to mimic behavior with respect to standard IO. Okay. So you get like a resource. Okay, interesting. Okay, yeah, that's the main, and then we have a test here. Not much new things here really. It's just same kind of thing. What is this? Smith? I'm not sure if I've seen this either. Used in conjunction with testing fuzz to generate. I mean, I know that they've done a whole bunch of stuff with this fuzzing testing thing, which I'm not familiar. I'm not too familiar with this fuzz example. Test 1. So, wait, this looks kind of weird. Fuzz. Oh yeah. Oh no. Sorry. I was thinking of something else. So, okay. So you provide a context void, is this here? A function that follows this, the signature, where you take a context and a Smith, and then options. Okay. All right. I just want to see a little bit how this is used here. Try passing fuzz to Zigbuild test to see if it manages to fail this test case. Okay. Well, let's see if we can build at all. Yep. Test fuzz. I've never done this. Like, I'm not even sure what's going on with this one. Rebuilding unit tests. Did it stop? No. Okay, it failed. Expected type. Okay. Whatever. I'm not gonna look into that right now. I'm not sure if that is, maybe it's a bug. I don't know. This is just a freshly Zig initted project. I would expect that command to work and not get a compiler error for that. Did I run the correct command? Yeah. So we got like a bunch of compiler errors. Huh. Okay. Anyway. So how would you, for example, let's see if we can just open, write to a file. So this is just to stand it out, right? So I mean, it would just be, instead of, so let's just open a file here. So this would be like output file. We got IO file. Actually, yeah, you do. Wait, do you still use standard FS? So this is how you did it before. You had the file system. Okay, so this is now apparently changed. So is it all in IO now? Dir, and then you would have like current working directory, and then create file. Yeah, so this is the same as before. Okay. And we're gonna try that. So now we have the file. And now instead of doing standard out here, we're gonna do output file writer. So this would be output file instead. I wonder if the file has convenience functions for this. Writer. Okay, so either you could initialize it directly through file writer, or you can get it from here, right? Like this. And then we got the actual writer here, interface. And if we run this now, we should just see it go into output. Yeah. Cool. All right. So, I mean, that's the main change. Like now you have this IO interface. You have to pass that around. Where's this file at? So this, you would get this from just creating a new project using creating a new directory and then going into it, and Zig init will create a new project where you're at your current working directory. And then this file is the main source/main here. I think if we do this, yeah. All right. I mean, yeah, that is like the huge, the most change, I guess, would be this IO thing. But then there's a whole bunch of other like language changes as well. I'm gonna check out build here, because there was some kind of changes to this, I think, or was that the next one maybe? I don't remember. This seems to be kind of the same. Yeah. All right. Cool. All right, so I guess I'm satisfied there. It wasn't that difficult, and this init thing is interesting as well. So, okay. Now let's go to the release notes. Whatever that was, somewhere. All right. We can skip this one. It's basically right. So the summary here. Most notably, the release distributes IO as an interface, but don't sleep on them. I mean, maybe we can check out more things with the IO as interface, but don't sleep on the language changes or enhancements to the compiler, build system, linker, fuzzer, and toolchain, which are also included in this release. And they're talking about support. So this is all different like support for different like architectures, I guess, operating systems. I'm not too interested in that. And here's the language changes. Switch, pack structs, and packed union may now be used as switch prong items. Great. They're compared solely based on the backend. Other newly implemented features. Wait, I just want to say that. So we have this new packed union. I've never used packed unions, but that is interesting. It, I guess, only takes up. Does it only take up like 2 bits? Because I think usually it's padded, the structs, or the unions, or structs, or whatever. Const u Switch you. Wait, what the hell is this now? Yo, Penguin, what's up? Okay, I've never seen this before. I think this is new. Is there pattern matching? Or like, okay. Declaration, literals, and everything else requiring a result type may now be used as switch prong items. Enum from int. Union tag captures are now allowed for all prongs, not just inline ones. Oh, now nice. Okay, so you can have like literals in here which will match. So it's like if they are the same. That's really cool. Also, I mean, it seems to work for more complex types. Yeah, I mean, before you would have a literal kind of like if it was a number or not a string, but a number. Actually, does strings work for this? Everything else, declaration literals, and everything else requiring a result type may now be used to switch prong items. Wait, let's try that. Just clearing everything out here. So we'll have this union, or sorry, we'll have a string one hello. Switch on string one. Does this work? Can I switch on strings? No. Okay. Just testing. You're jealous about auto completion, like when you're inside dot here? Yeah, you mean like... I mean, yeah, so if you have like this one, struct 1, 2... Yeah, and see, it doesn't work. Wait, I have to add the type, of course. Now it works. Okay, cool. But if you, let's say, if we have like an enum, let's do a tag union, and I want to switch on it, and switch. Say this is one. Switch on this. Oh, we do get these, but sometimes you don't get these in a switch, or yeah, there are some. I'm not sure if it's like because of how the syntax parser or the parser is like failing to understand the tree, and then you don't get like, because you have like incomplete code essentially at this point, and it doesn't understand. So I'm not sure. Sometimes it doesn't work. Sometimes it does work. How is Helix working for you otherwise? Like, don't you have any auto completion, or is it only? I mean, it might just be the ZLS version you're using. Maybe. Have you upgraded to 0.16 and ZLS to 0.16 as well? Okay, but this is kind of cool, I guess. Unit tag captures are now allowed for all prongs, not just inline ones. So that's cool as well. Switch prongs may contain errors which are not in the error set being switched on. Okay. Let's see if I can read this without crossing my brain things. Switch prongs may contain errors which are not in the error set being switched on if these prongs contain comp time unreachable. What the hell? Okay. Switch prongs captures may no longer all be discarded. Like, I'm not sure when this is useful. I guess it's, I mean, yeah. It might be useful when you're doing comp time stuff. I can't really see right now how an example of this. But, okay, switch prong captures may no longer all be discarded. What? Switch prong captures may no longer all be discarded. Why not? Omit it. Oh. Okay, I mean, sure. It's just, I see, okay. I don't understand why, but sure. I don't see the difference, but sure. ZLS is 0.16.0, yes. So I showed it earlier, like you can, well, I use something called ZVM, which is the Zig version manager. And that one you can use to install 0.16.0. So this would install Zig. And if you add --ZLS, it will install ZLS. Hello, Mutasemos. Welcome back. So there you go. What is the font? The font is called Hasklug, I think. 1 second. I always have to. It's either Hasklug or Hasklig. It's like, it's a nerd font, I think it's called. Hasklig, probably. There you go. All right. Okay. So cool. All right. I mean, it's not really huge thing. Bug fixes. A lot of issues switching one possible values types are now fixed. The rules around original. Switching on void no longer requires an else prong unconditionally. Switching on void. When would you do that? Like, there's only one possibility, I guess. It's void. It's going to be void, right? I don't know. It feels weird to switch on void. But okay, maybe there's a use case for that. There's so many weird things going on about that. Okay, lazy values are properly resolved before any comparisons with prong items. Okay, cool. Maybe this will solve some of those issues with LSP as well. I don't know. Evaluation order between all kinds of switches are not the same with or without label. Okay. Quality comparisons, packed unions. This used to be already possible. Wrapping packed unit to a packed struct. Now it's also possible to have do that. Equality comparisons. I wish I had an example of that. So you can compare. Wait, yeah, because packed unions, you can compare if it's a tag. I'm not sure if that's what they mean. If it's a specific tag. I don't know. Yeah, this one is interesting. C import moving to build system. In the future, C translation will be handled with a build system rather than the C import language built-in, which is now deprecated. Wow, okay, cool. Upgrade guide. So is this in the future or is it now? It says in the future it will handle by the build system. Okay, so before we used to have something like this. You have a Zig module which defines all of the things you need from C. Yes. So you would have the C import in here, and you C include everything from C here. So when you import this file like this, you import the Zig module, and then you .c for getting this constant here. You would have access to basically everything that C exports on this C binding. So here's the new thing, I guess. We have a header file, a C header file instead, okay. And then the build.zig file will translate C. So is this how you're supposed to do this now? By doing this, okay, so let's see what they're doing. So they're using translate C. That's the source file, the header file, okay. And then we link some libraries. Great. And then we just add it as an import here. Create module from translate. Okay. Simple enough. And then you simply import the module C instead of the file as a module. Yeah. Okay. I was saying module here before. This is really just a file. But yeah. Here is an actual like build system module that has a alias C or name C that you import like this. By doing this, the translated C code will be identical to how it was before we C import. So that's pretty cool. I mean, I think I like that because it's kind of moving away from having this in the language itself and instead using the build system to create this module for us. And that will open up other possibilities of possibly interfacing with other languages through the build system, creating Zig modules there. I'm not sure what other things, because there are other things that is specific to C though, which is like the ABI thing, where you can create a C-like function definition. With a C ABI, you can, yeah, and I mean you have the C pointers, like it's pretty ingrained within the language, the whole C thing. So I'm not sure if they're trying to move away from that, or if this is just a convenient change to have. I don't know. But anyway, it's probably better to have it like this. Probably. I mean, yeah, whatever. It's not a big change anyway. So. You just have to use the translate, and it also forces people to learn about translate C, which is cool. It wasn't that complex, so that's nice. By doing this, I appreciate the example they give here as well. By doing this translate sequence, yeah. Alternately, you can add the official translate C package as an explicit dependency and gain access to more translation customization options. Oh, I see. The official translate C package. I'm not sure if I've seen any official packages before. I mean, there might be. I just haven't seen them. Okay, interesting. You saw the typo too, yeah. At type replaced with individual type creating build. Yeah. So we looked at this yesterday. This is also pretty cool. I think it's gonna be way easier to define types like this now instead of using that type built-in thing. So before we used the type built-in, and they just call it built-in. Do you call it built-in functions or built-in functions, I guess. at type building function. But the problem was that you had to provide this struct thing, which was kind of unwieldy to create. So this seems a lot more. I think the worst things to create was the fields of a struct, I feel like. Especially if you have a dynamic list of fields that you want to build up from other information. Because of how, I mean, it's possible, it's just that it's a bit unwieldy. Because you have to deal with the comp time arrays that you concatenate and modify. By the way, a few things seem AI. I'm not surprised. But it does. I've not gotten that feel of this yet to like have something AI here, but not yet. I mean, yeah, I'm just skimming through. I feel good reading Zig, but I see very few production level libraries to make a bread out of it. But 10 years is a lot. Yeah, I mean, people have the what is it? I think is it called a Tiger database? They created a whole database written in Zig, I believe, which is apparently used in the financial Tiger Beetle. Yeah, okay, Tiger Beetle sector. So that is pretty impressive, actually. That is, I mean, yeah, I feel bad about the breaking changes all the time, but but yeah, that is impressive. Since when have you been using Zig? Are you asking me or Z? I've been using Zig. It's coming on 2 years in maybe November. So I started with 0.13, I believe it was back then. All right, cool. So enum literal. Enum literal such an enum literal type. Are they just going through everything here? Which is a type of anchors, enum literals like .foo. This is something that I quite don't really have a good grip on because I'm not using it that much. Like the enum literal, like it's like you have a enum literal like .foo without any result type or like expected type. So it basically becomes like an untyped enum literal, which apparently can be used for any enum that has the same literal, like, or something like that. I'm not sure exactly. This is still eluding me a little bit. When is Rust 2 coming out? We're on 1.95. I have no idea. Maybe we'll do a try Rust stream sometime, but I doubt it. We'll see. When it's equivalent to type of dot something, the new enum literal is preferred for the consistency. Okay. Yeah, I'm not sure, actually. So type enum literal is enum literal. Okay. Integer. Right. So this is a good example of how this is better. So before we had to do like at type and we had to have a struct. This is a union tag union where it's the int version, and then you have to provide these things. Instead, we have now int. And a better like interface for creating this int here. So really good, really cool. Oh my god! And just look at this, because you have to a tuple is a struct with is tuple is true, no declarations, which also has to be defined, even though it's basically always an empty string or an empty list, because you can't actually define declarations like this. So it's always going to be Okay, anyway. And then the fields like this, right? And now we just do this. Wow. And if you want more details, like if you want to change alignment and stuff, you can actually, I think you can just say that in the type itself. Yeah, that's really nice. You provide a tuple or like an array of types instead. This is really extremely nice. Simplified language is no longer possible to reify tuple types with comp time fields. I have no idea what that means. Please try Rust again. I mean, if you're gonna, as we say in Swedish, köta, maybe. At pointer returns a pointer type equivalent to at type. I mean, it's gonna be interesting to see. Like, if I try Rust, it's gonna be interesting to see like the comparison between Zig and Rust. And I don't know. I like Zig because it kind of enables you to do whatever you want. It feels like, whereas Rust is the other way around, probably. I don't know. That's the feeling I get from it anyway. All right, so a bunch of these, you know, very, very useful things for if you want to create a bunch of dynamic types. Float, there is no float building because there are only 5 runtime floating point types, so this function is trivially implemented in user land. The function standard meta float can be used if creating float types from a bit count is required. Okay. Right. Array, there's no array built up because the function array length element, you get a type. Yeah, and can't you also just have a type expression? I don't know. In practice, generate is not usually necessary, but the size can simply be replaced by, yeah. Opaque, is that right? Opaque. Okay. Allow small integer types to coercive. Yeah, so we've seen this also. If you have an so coercion is very limited in Zig, because sometimes it's like you don't. It's ambiguous on how you want to convert things. This kind of says that it can overflow. Or, yeah, just so that you're aware that things can get truncated or changed. What's new? Yeah, we're going through a little bit here. You'll drown in features? How do you mean? Forbid runtime vector indexes. Right, so we saw this also. I was a bit confused, but I guess whatever. You probably don't do this anyway, looping through a vector like this, because vectors are, the purpose is to do many things at once, not loop through it. But if you really want to do it, you kind of convert it to an array. I mean, I guess just using types and then, because it's essentially just an array. It's just that the type is a vector. So you basically, you just coerce it to an array. And run it like this. Okay. And then it's like, it changes for the reworked Bible syntax lowering. When writing self-hosted compilers, an early experiment to attempt to slightly reduce the number of intermediate instructions emitted in the pipeline by lowering expressions with bi-val semantics. The experiment was a failure because it led to the following issues: array access performance issues, surprising aliasing despite explicit copy, extremely poor code quality in degenerate cases. The frontend now lowers expression by ref until final load, fixing all those issues. Okay. I don't know what that means, but seems fine. Oh shit. Yeah, okay, we're over here. Vectors and array no longer support in-memory coercion. Oh, you'll drown new features in Rust. Yeah, maybe. Trying out Rust and played Rust the game? No. Twitch stopped working? What? Like for you only, or do you think? Because I seem to have people watching. I don't know. Hello Subadara, what's up? Did they change input taking method or is the same? I mean, for the IO part, there's like there's not much changes regarding like how you do things. It's just that now you have to pass an IO binding everywhere. It's just you just have to add an argument to everything. I showed that in the beginning. See if we can go back. So here, whoops. So here we're opening a file. This is like usual, except now you have to pass an IO. And I'm not sure what this actually has in it, to be honest. They're probably gonna show a little bit of this, but and what the different like implementations are for this. I guess we can see some here. Threaded, evented, dispatch, KQ, Uring. Not all of these are different IO implementations though. Yeah, so that's the big thing. Like, and you also get an IO from main. So this, you get this thing, which includes an IO. So you can just use that. You don't have to create your own. How did you install ZVM? I don't know. I think I installed it. I mean, I think it's simply, yeah, just go to the ZVM homepage and follow the guide there. Posted a link there. All right. So Victor is not memory coercion. If you're using pointer cask, okay, sure. Forbid trivial local address return from function. Yeah, so this is also interesting. This returns an error, or I guess this would be an error now. We could try it. Or maybe not. Maybe I need to use it. No. Okay, so that is not an error. But okay, so if you have x is and I32 equals to 5, return x. This should be an error. There we go. Wait. Okay, var. There we go. Now we get the error. So returning address of, ignore that we got 2 of them. This is just how my setup is in NeoVim. I need to fix that. Returning address of expired local variable x. So that's the new error that you get because of a misunderstanding on how like this works. So this is a local variable in the foo function. So this would be when you call foo, this is allocated on the stack. But when the function ends, the stack for this function will disappear and be invalidated, so you cannot use this as an address to be returned. I mean, you can use it as an address inside here, so we can do like, I don't know, this perhaps. Can you do this? No? Yes, you can. Okay. So you can use the address while in the function, but not when it's returned, which is really nice because it yeah, I think I was gonna say new players, but new programmers who are not familiar with these kinds of things like the stack and the heap and allocating stuff, and you know, they're used to garbage collected languages. Those that are not familiar with these manual memory managed languages maybe oftentimes did this and got like a seg fault or something later on and didn't understand what was happening and maybe quit Zig and cursed it to oblivion. But this gives you an error now instead, so that's really nice. I mean, I got this. I was actually confused about this at the start as well, because yeah, you have to basically hammer in how to deal with this at some point. All right, so that's pretty good. Yeah, and here's the test here, that you have a var x and then you return this. This will be an error now. Unary float built-in's forward result type. Previously, Zig would not forward a result type through the following built-in functions. This has now been changed, where previous you couldn't write const x is a f64. Ah, see here. So, right, so I understand what is going on because I've been dealing with this a lot. It's like you have this at float from it. This is happening inside here. So you would get a complaint where it's like, oh, I don't know which float type you want this to be. When you clearly can see there's only one possibility really here. I mean, or yeah, I mean, we know the result type should be f64, but before you had to have add an at as here, f64, wrapping this in that to make it understand that this is actually, but now this one will forward the type into its argument, I guess, what's happening. Yeah, and so then you don't have to wrap it with an at as here. Cool. This is part of a larger effort to improve ergonomics for making video games in Zig. Wow. Hey. Wow, I didn't know about that. That's really cool. So that means that there's probably gonna be more changes that makes it easier to make games in Zig. That's awesome. Okay, at floor, at ceiling, at round, at trunk, conversion to integers. Okay, that is also really nice because it's like when you do at trunk, you oftentimes want to convert from a floating point to an integer type, but it wasn't like implicit. You had to explicitly tell it to int from float, but I guess now it's like implicitly converting. That's also really nice. I mean, it's almost like cheating now. We're almost cheating at this point by doing this only. Okay, really nice. They're fixing kind of the friction that you get from dealing with these conversions here. Really cool. And yes, that's good. Forbid unused bits in packed unions. Okay, fine, whatever. Forbid pointers in packed structs and unions. Huh. Fields of packed struct and packed union types are no longer permitted to have to be pointers of fields. Yeah. Implementing okay. The primary reason for this change is the constant values containing non-byte aligned pointers cannot be represented in the vast majority of binary formats. The primary reason for this change is the constant values containing non-byte aligned pointers cannot be represented in the vast majority of binary formats. Okay, whatever. I'm not using packed structs and stuff like that, so I don't really care. Allow explicit backing integers on packed unions. Although previous versions of Zig allow packed struct types to specify their backing integer type with the syntax packed struct t, this was not previously permitted by the packed union types. Okay. Forbid enum and packed types with implicit backing types in external context. Is cheating. I would prefer Zig to not to be so implicit now. I mean, I was joking. I mean, I don't know. It just feels like the philosophy. I mean, I might have misunderstood or thought that was the philosophy to make those like conversions very visible, like explicit, so that you can kind of feel that okay, now we're making a conversion here, and it's not like a free operation. However, I would say like okay, if you truncate, that is an operation that could possibly maybe be free. I don't know, because I don't know. It depends. I guess you would have to kind of, I guess, compare instructions and stuff. But I was just joking a little bit. It's just that it has been a very cumbersome to kind of convert from integers to floats and vice versa. And I appreciate the fact that you have to be explicit to convert, and also choose how it's converted. Do you want to round the float number? Do you want to truncate it? Do you want to ceiling or floor or whatever? So that I appreciate that you have to do something, but why would you need to say truncate it and also convert to an integer? Because it's already truncated, so it should be trivial to just say it's an integer now. But yeah, so that's what they did. So that's really, I think that's really nice. Forbid enum and packed types with implicit backing types in external context. Forbid enum and packed types with implicit backing types in external context. Okay, fine. Lazy field analysis. A problem we noticed since introducing IO as an interface is that if a type is used as a namespace, its fields will be analyzed anyway. For example, using standard IO writer in any way pulls the table, the v table of standard IO. Some cases of this could even result in unnecessary code gen, which can bloat binaries. Okay. Now struct, reminder that files are structs, yeah. Union, enum, and ironic files are functions. Struct, union, enum, and opaque are only resolved when its size or the type of one of its fields is required. This means that not only can you use types as namespaces without referencing them, but you can even use non-dereference pointers without needing T to be resolved. Okay, I need to read this like 10 more times. Struct, union, enum, and opaque are only resolved when its size or the type of one of its fields is required. So it's like tree shaking a little bit. This means that not only can you use types as namespaces without referencing them, but you can even use non-dereferenced pointers without okay. I don't really understand, but that's probably pretty cool. Pointers to comp time only types are no longer comp time only. Alright, see you later, Penguin. Pointers to comp time only types are no longer comp time only. Comp time only types, for instance, through comp time int is a comp time only type. Oh, pointer to comp time int is not, and neither is array of comp time int or slice. This may seem confusing at first. The easiest way to understand is consider function pointers. The type is a runtime type. However, you're not allowed to dereference it at runtime because the element type, the function body type, is comp time only. So these pointers can exist at runtime but only dereferenced at compile time. This makes them more or less useless at runtime. Well, not really. I mean, you can change the function. This makes them more or less useless. Okay, I guess I understand what I mean. But there's actually an exception to that. Suppose you have a slice of constant struct fields and you want to pass the name of each field to runtime code somehow. Previously, you would have to done this by constructing a separate array or slice. However, now you can pass the slice directly to a runtime function. Naturally, this function cannot load a struct field from the slice at runtime. However, what it can do is load a name field because it has a runtime type. Also, yeah, and yeah, kind of like the array length as well. Like array length was already working like this, right? Because the array length, the slice length is runtime known, but the array length is comp time known, right? But I'm pretty sure you could access it and use it as a range parameter argument. Okay, that's pretty cool. Easier to work with comp time types. Cool. Explicitly aligned pointer types now distinct from natural aligned pointer types. Cool, okay. Previously, this was considered by Zig to be literally the same type. They would compare equal and was considered a canonical spelling. It's what the compiler would print. Now these two types are no longer considered equivalent. I mean, this would set like, so, I mean, they both would have the same, like if we take the struct that is the type, they would have the same fields, right? And depending on the values of those fields, it would be considered equal or not equal, depending on, like if the align is defaulted to be 1, wouldn't they be the same? Crucially, the two types can still be used interchangeably. They coerce into one another, even though pointers, what the compiler calls in-memory coercions. And in almost every case, there's no need to care which one you have. You could think of this difference as being like the difference between U32 and CUint, which is also the same kind of same type. Technically, they are different types, but assuming your target has 32-bit int, they are identical for all intents and purposes, and it doesn't technically matter which one you pick. W or L update? It's I think it's a W. It's very W. I mean, there's no. It's not like there's changes that I don't like. It's probably. I mean, there's changes I don't understand, but it's probably for the better. I really trust the people behind this. I think they are moving in a really good direction. I've not seen anything that I just like, oh man, this makes me not wanna use Zig, you know. I think every change here is very good that I've seen so far. So I probably won't see like any like updates that are actually bad. I don't know. I mean, sure, passing the IO around is like you could see it as a like more inconvenient, but I don't know. It also allows for different implementations, so it's like I don't know. I don't see it as a huge thing, but I'm not sure what people would be not happy about with this update. Less excitement on Zigit. Could you point me to anywhere where it would be less excitement, or I've never been there, so I don't know. All right, blah 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 blah. Okay, I think we were over here. All right, simplified dependency loop rules. There are new cases which are now dependency loops when they previously were not. Interesting. However, it's more obvious why a dependency loop exists due to simplified type checking rules and enhanced compilers. This also reduces the difficulty of formally specifying the Zig language. Cool. This was changed as part of reworked type resolution. Are they actually formally specifying the Zig language? This is one of the things that I never want to actually do, like formally define a language. This just seems like too much work for a hobby language. But yeah. Okay, type resolution, cool. Second thread, this one. Okay. I mean, I'm not, is it this one you mean? I don't really use threads, so, but let's see if we can, if it's this one. Okay, something is saddening this person. I'm developing a cross-platform queue library and I conducted some basic performance tests. However, the removal of thread users and thread fut. What is this? Like, I know what a mutex is, but what is a futex? From the synchronization primitive saddens me. I believe they should be retained. Currently using IO futex wait seems to spawn a new thread, which is not what I want. What is formally defining a language? So, from my understanding, it's more like you define a mathematically formal definition of the language so that you can kind of prove that it is well defined, which is like saying that you know that some things are gonna work in the language. Some, like, you can define like ultimate rules that it's gonna that the compiler or the language will work as you intend it to work, so that there's no like weird edge case where you can basically break the whole thing or something like that. Pretty badly explained, but it's essentially just to have a mathematical kind of proof that maybe that's not the formal definition, but you know, it's to have a more mathematical formal definition of the language, and whatever you gain from that is good, probably. Currently, okay. So they removed these things. All queues have a capacity of 256 with a tensor. Like, if it's theoretical possible, practical possible too. I think it's like, let's say, for example, the type systems are usually also like a big thing in this. where you formally define the type system, and you can have a you can be sure that it doesn't break at some point. There's no edge case somewhere where it just doesn't work, so that you can use it as it's intended, basically. I don't know. I've never actually done that. I mean, yeah, that is you have to go into some deep, heavy like mathematics to do that. I have kind of studied a little bit on that type of formal definition thing, but yeah, it just felt like too much work for not much. Well, I wanted to build a language, not just imagining some. I think it's useful if you already have a working kind of language and you want to kind of have an official, like, serious release of the language. Then you might want to have it. Okay, let's see. It doesn't do that. Automatically checks if the value at pointer equals expected, and so it blocks until. Like, I don't even know what a futex is. Fast user space mutex, a Linux kernel mechanism that enables highly efficient locking and synchronous multiple threads, primarily keeping fast path of locking. Okay, so it's essentially a mutex, I guess. It avoids expensive kernel system costs unless a thread actually needs to sleep, significantly improving performance. So it's like a fast mutex, okay? Have you tried updating standard thread mutex to IO mutex as well as thread spawning to IO concurrence? Performance drop. I mean, again, it's like it's not even a released language, but yeah, I guess it's good to know that if performance is like going down, but then it's also like, is it used in the correct way? I don't know. Like, I don't really know about these things. This is interesting. I wish there was an option for users. I'd really like to see standard thread music, standard and condition added back. I mean, is it just that they moved it though to IO, or is it like a different thing? I'm confused. There's nothing standard doesn't have either independent synchronization primitive threads because they would not mix with IO. IO has to be aware of synchronization. I see. So he wants mutex without the IO, I guess. Now Zig being systems programming language whether you're pulling all basket not having lower abstractions like in Zig 15 for this design decision for sure. If you write systems code, you can probably also write better code than those portable abstractions. One thing is sure, that if Zig 0.16 program does IO without going through given IO instance, the program may block for uncertain amount of time. Or in worst case, infinitely if mixing IO synchronization. So, okay, I see. So because we're going through the IO instance, there's like there's like, because you have to, there's one dereferencing happening when going through the interface that didn't happen before. So that I understand that one. I do understand as a downgrade if that's the case, that you have to go through the IO interface for that you didn't have to do before. So okay, yeah, I do kind of agree with that. But it seems like the mutex is on IO, or wait. Or maybe not. Yes, it is here. Mutex is a synchronization primitive which enforces automatic access to shared reader. But this doesn't have the IO though, or it does have. Oh, you have to pass IO. What does it do with IO here? Mutex wait. Oh. See replies at the end. Not green code, find cell, what next items that gets it hints at what is within reach. Ideal easy stuff is easy and the hard stuff is possible. The language is well positioned for many different use cases, just a main confident step into the right direction. Juicy main. Is that what the hell does that mean? Is that a new term here? Because you said it before. This would allow you to your code to run in environments where traditional threading is not available, provided that there is an AIO implementation for that environment. This is exactly what I'm afraid of. What's to be afraid of that? I mean, this is even. I could use this to implement a thing. I could actually. In my VM in Runic, I could actually implement an interface for that VM and use the IO interface through that to have an abstracted version of the code to work with that environment. Which one we're talking about again? This thing here? Okay. I'm gonna continue looking through here to see, because they probably go through here's like standard library. Juicy main. Juicy main. What the hell is that? starting in Zig 0.16.0. Okay, it's just that they provide a bunch of convenient things to main. That we saw. I mean, okay. So are people like upset about this? A standard set of pre-initialized useful APIs, because I don't think you have to use this, right? If you don't provide, you can either go for the minimal, which is the arguments and environment. Okay, maybe you don't need the environment, so you don't need to read them in. I don't know if anything happens here, or if it's like already read in, or if you have to kind of call something to read. I don't know. Yeah, so you have this init, which is, I mean, I don't know. I think it's really nice. I would say a few people don't like how they reordered IO in a few spots. Reordered. What do you mean reordered? Like how in the argument list or what? Or do you mean that they moved some interfaces to I/O? Or I mean some types and stuff. Because yeah, basically everything in the file system was moved to I/O as far as I can tell. Except for the path. The docs are lacking right now. Yeah. I mean, again, it's not even a released language. It's still like in a very early stage, I would say. So I would expect that to be the case. I would expect the docs not to be fully implemented. The language is gonna change. They need to have this. They need to have the language malleable so that they can find the direction they want to go and then go in that direction. So I would expect these kinds of changes to happen. But I understand if people feel like it's the wrong direction, or if they're not happy with some of the changes. Like, I can understand that. And raise issues if the performance goes down from a change. I don't have a problem with that. But this seems to be like an optional thing that you can use if you want. So I don't really see a problem with this. Yeah. Yeah, user main is the init argument. Yeah, I thought it was a nice change to get. Like, the only downside I could see is like that if you take this variable, it's gonna take a little bit of startup time or whatever, startup memory or whatever, to actually get this in here. But yeah, that. If you don't have, as I said, you don't have to use it. You can create your own GPA, your own I/O, I guess. Everything, yeah. So I don't see why it would be such an issue. Production grade Tiger Beta might suffer from drops. Yeah, but that's also a thing. Like, you have to understand, like, it's still a very new. I mean, yeah, the language has existed for 10 years, but it's not released. It's not like. Yes, it's bad if the performance goes down, but you have to kind of take that risk. That's the risk they took when they chose to take like almost kind of like an experimental language to base their product on. So I think, if they didn't think that was a risk, that was probably like a miscalculation in that case. So I don't know. I mean, they probably. I'm not sure if they have said anything, but from this thread, someone is upset anyway. But yeah, I guess. Well, here's Andrew. I guess Andrew. Wait, Andrew was the first. Okay. But no response to the benchmark. I remember Andrew saying Zig would be 1.0 by now. I mean, okay. When did he say that? Because that's it's a classic problem in software development. See his tracking issue link. I thought I saw it somewhere. Yeah, it's this site is like you can't search, things disappear. I saw it somewhere, the tracking issue thing. Yo, Borochecker! What's up, what's up? Hang on. I need to check my notifications here. Oh. Scriptable Zig. Yeah, Runic. Yeah, I mean, I've basically stopped streaming Runic because I feel like I reached a point where it, yeah, kind of the MVP was done basically, and it's still ongoing. Like I still like work on it a little bit, and I even have like a person contribute as well, so it is kind of living on a little bit behind the scenes, but I probably won't do a huge amount of work on it, but yeah, and I mean it's probably gonna stay kind of as it is right now, but yeah, we'll see how much will be done on it. But it's probably gonna improve if I like when I start to use it in my normal workflow and see like, oh well, this would be nice, or encounter a bug, okay, let's fix this bug or something like that, you know. The new IO, but if people like use it and, you know, report stuff, I will also be active and you know, try to fix that stuff as well. The new iOS also missed the event that is not complete. Yeah, I need to check out how this actually works. But anyway, I don't see that post here. The tracking. Here. Wait, where did they say that it was be 1.0 by now? What you could do is take inspiration from Lisette, basically Rust. IC scripting language that looks and feels like Go and interops with Go. You could do similar Zig, but scriptable, embeddable, interop with Zig, libs, and C naturally. Huh. I don't know, man. I would have to give that a think. I'm still baffled that Zig is taking so long to stable version 1. They have a lot of people working on it, and I feel like, I mean, I don't mind. Better to take time to do the right thing than to rush out, you know, some half-ass thing. Zig and Rust are pretty much the same age. But Rust still uses LLVM, right? Lisette.run. A little language inspired by Rust that compiles to Go. That's so weird. Rust is a more complex language, so how the heck would that get version 1 in 2015? Zig is still going. Wait, but when did the Rust start? I mean, Zig, I think Zig started in like 2014 or 16 or something like that. ...2016 was the first version. So it's not real. They're not equal age. And okay, so version 1 from Rust also took 10 years. Started in 2006. When did development of Zig start? So it started. So they would be. So Zig would be kind of the same age as Rust was when Rust was version 1. So Rust took 10 years to get to version 1, or 9 years or whatever. And that's when Zig started. So if it had the same, if it was Rust, it would have been done now. All right. Well, okay. So juicy main. If it's missing, the empty main is still empty main param is still legal. However, it now means you can't access CLI algorithms environment variables. Oh, wait. So you have to use minimal if you want to do that. But because before you didn't have to do that, you could use like you can access through another interface. So I guess now you have to do that. Well, I mean, I guess. Wait, I don't remember how you get the arguments from. I don't remember how you get the arguments if you're not using like a. If you're just using like assembly or something like that. Earliest Git commits came from 2011. I mean, personal project as a researcher at Mozilla. Okay. I mean, if you're gonna compare, I would say to you're gonna compare the actual beginning, but yeah. So if it's a little bit cheating just to jump forward, but yeah. But anyway, it's still Rust was still faster if you're gonna just compare version 1. Because it would have been version 1 by now for Zig in that case. Yeah. I mean, as I said, I don't really mind it taking time. As I said, like better that it takes time and becomes a good, like a better than it would have been if you would take less time. And they have like almost 250 people working, contributing, which is pretty good, I would say. I don't know how many are working on Rust, but yeah. Okay. Where were we? Standard library. Removed segmented list. Okay, very good. These were like deprecated. Counting meter, never used that. Mutex recursive. Yeah, I don't know what that is. Error set changes. Okay, sure. Good to know if you run into any of these errors. Uncategorized changes. Formatter alt. So it's just a type change. We don't really care about that because you never see this type anyway. Or I might be reading this wrong. Format into print. Right, I don't think I've ever used this one. Okay. Yeah, this makes sense because a sentinel might not be a 0, so compress. Okay. I/O as an interface. Starting with Zig 0.16.0. All input and output functionality requires being passed an I/O interface or instance. Generally, anything that potentially blocks control flow or introduces non-determinism is grounds for being owned by the I/O interface. Non-determinism. I mean, what if you allocate... you allocate a bunch, some memory, and you don't initialize it. That should also be kind of like non-determinism. Oh, yeah. Anyway, because you get like whatever's garbage was there from the beginning. I'd want to use Zig, but not in a state where it keeps breaking public API. You do one thing now, suddenly you can't do this anymore. Yeah, and that's also like that's what you have to, and that's fair. You know, you can look at the state of the language, decide that you don't want to use it based on how it's evolving, and that's just the way it is. And you know, as long as we know that that's going to be the case, then we can decide, okay, well, I don't want to use it, or I want to use it, but be aware that I need to update my code in the future whenever we need to update the Zig version. But you can't like use it and then complain that there's a bunch of breaking changes, because that would have been part of your risk assessment of using the language to start with. I mean, that's just my opinion anyway. Zig's take inspiration from Zig standard is very clean. Yeah, I really like. I mean, I love a lot of things about Zig. Finally found interview with Zig language creator Andrew Kelly at 16. Okay, so the only thing that I want to see is when this interview was made, and then I'll make a. So interview with Andrew Kelly. No. With Zig Language Creator. Oh my god, come on. What? Yeah, okay. Fair enough. Okay, so that's the thing. The problem with software development is like whenever you're estimating something, if it's more than, I don't know, a month or a couple of weeks, it's probably wrong. Like the estimation is always wrong. So there you go. It's like, yeah, that's just how it is. And especially with the more complex a task is, like creating a compiler, like a program language, it's an insanely complex task. If you want to make it like a Zig, then the estimation will be like all over the place, you know. Oh yeah, you couldn't hear. Oh yeah, sorry. He was saying like, when would you estimate? So this was 2020, so 6 years ago. So he said like, the interviewer asked, when do you think 1.0 will come out, and he laughed and said like, yeah, I don't want to set a date, but let's say 2 years from now. And if you wait 2 years and ask me again, I would say the same thing. So yeah. so he essentially said we would have been out 2022, so that's 4 years ago. But yeah, as I said, like it's impossible to say, and I think that's good. You don't want to set a deadline for this because that's just stupid, to be honest. Like, let it take the time it has to take, and that's it. Like, don't, because the only thing you're doing is that you're gonna make it worse, basically, if you're forcing it to be released just because you said it would be released. I won't call Zig a successor to C. That hand goes to C3. Yeah, I mean, to be honest, I don't really care about those discussions. Like, is it a successor to C? Is it like so? Whatever. It's Zig is Zig, C is C. It's like discussing, I don't know, music genres. Like, what kind of genre is this music? It's like, well, maybe it doesn't. Maybe, I don't know. Maybe it doesn't have a genre. Maybe I don't really care about genres. It's like, this song is this song, whatever. It might be due to Zig not having as much contribution sponsors as Rust did at the time, since the big Jumpstart was probably being company sponsored. Yeah, probably. I'd say that's where one cheated. Yeah. Well, we'll take that as a reason. Some people call it a successor in a spiritual sense. I'd say Fightback only successor is a direct subset, not a whole other. C3 does that, so it is just what it is. I mean, okay, when you talk about successor, what does that really mean? Like, if you make a movie and you call it something, and then you're like, well, I want to make like a successor to this movie. Is it up to the viewer to decide if this is a successor, or is it officially the successor, but then it's like the viewer could decide, hey, this is not, because this is not like the first one, so it can't possibly be a successor. It's about different people, different setting, so they decide that, hey, this is not a successor. I just think it's what does that even give us? It's just like saying like, well, it's similar to this language. I would be it just creates a bunch of discussions that just doesn't do anything for me. So undefined behavior is a feature. What do you mean? Defines the successor as a stable, up to modern standards, equivalent of an old, which looks and feels quite like old, but resolves many of the issues of the old while retaining compatibility and interop. Yeah, but that's your definition, and you might have other people who has other definitions, and maybe have more broader definitions to accept other languages like a successor. Like, what do we really gain from defining ultimately who is the correct successor of this and this language? Like, what does that give us? Like, it just feels like pointless discussions to me. But you could say, like, what I would say is useful, would say like, yeah, it's kind of like C, like it has the same kind of features. It's a low-level language. You can write assembly if you want, manual memory management, and so on and so forth. So you can make comparisons, and that will give you an idea of what this new language is. But then saying like, yeah, it's a successor, that could honestly, it could mean like anything. I mean, the only thing you could be sure is like, yeah, it probably has some of the features, probably looks the same, but you don't get much more than that from just saying it's a successor. Zig is its own space. Still see people jump about, is Zig the new C? Zig will overtake C. Yeah, okay, it's actually fair. That is one thing that is, I've seen somewhere that potentially Zig could replace C, but is that gonna happen? Who knows? Like, because of the way it's built, because of the way it can replace C by rewriting things incrementally in Zig, and then have the C interoperability between Zig and C, and then incrementally replace everything with Zig. So that is a possibility that could happen, but is it going to happen? I don't know. Probably not, for a while at least. If they want that, go with C3. I mean, that depends. Do they want to use C3 or do they want to use Zig? It's like, since it has like C interoperability, and probably will always have, it doesn't really matter, I guess, what you use. Maybe we'll end up getting like this whole family of C compatible languages that all live together. It's quite hard to replace C due to the history and the way C itself is used in almost anything. No, the point is that with Zig, you can take, let's say a maintainer or whatever want to replace a C library with Zig. They're tired of using C. They see Zig. They see rainbows and sunshine over there, and they wanna use C or Zig. So what they can do is just start to replace like sections of their library, whatever they have, from C to Zig, and then have the interoperability to still have the library work, even for people who use the library with C. So it will still be able to be used by other C programs or C libraries, but some of the things have been rewritten in Zig, and then you just continue to and at the end everything would have been rewritten into Zig. So now it's a Zig project. Zig is essentially assimilating the C projects like that, if they choose to do that. But that's the crux of it. Like, do they want to do that? I mean, it's up to them. So that's what I mean. Like, but it can potentially replace C by that mechanism. It has the potential to do it, but it also, like, yeah, people have to decide to do that as well. So even though C is like in almost anything, and so that doesn't really matter because of how, like, what kind of like how the interoperability works with Zig. As far as I understand, like that's the idea anyway. Okay. Along with the interface, I'm not sure if my thoughts came through there, but yeah. Along with the interface, this release comes with the following implementations: IO threaded based on threads. With this implementation, IO operations are straightforward. For example, file system operations directly call blah blah blah. When updating code for Zig 0.15, using this implementation provides the equivalent behavior. This implementation is feature complete and well tested using cancellation. Okay. Lol. Lest one learn a lone release lesson, proclaim cancellation should seriously only be spelled thusly single L. Let not evil godless liars lead a foul. There's a lot of L's in there. In the same vein as breaking out of a for loop early, once you start doing multiple tasks concurrently, you start running into situations where one task having completed, for example by failing, means that you would like to interrupt other ongoing tasks since their results and or side effects are already known to not matter, or perhaps even require being reversed. Future, group, and batch APIs all support requesting cancellation. When cancellation is requested, the request may or may not be acknowledged. Acknowledged cancellation requests cause IO operations to return error cancelled. Even IO threaded supports cancellation by sending a signal to a thread causing blocking syscalls to return inter and responding to that error code by checking for a cancellation request before retrying the syscall. Only the logic that made the cancellation request can soundly ignore an error cancelled. Otherwise, there are three ways to handle error cancel in the order of the most common: propagated after receiving it, IO recancel, and then don't propagate it. This rearms the cancellation request so that the next check will have a chance to detect and acknowledge the request, make it unreachable with IO swap cancel protection. Okay, cool. Yeah, so I mean, it's kind of like, man, what is it? C# tasks have a cancellation token that I think fills the same kind of purpose there. So I'm familiar with this type of idea, that you would have something, a bunch of async things happening, but someone cancels the whole operation and you want to cancel everything, and you can do that with some type of signal being sent somewhere. So yeah, cool. Exactly how it works, I'm not sure, especially since I'm not really using like anything like this. Like in my project, I've actually never used in Zig, I've never used any kind of async programming or multi-threaded programming, so maybe that will be a test we can do at some point. But okay, right, so this is the IO threaded implementation based on threads. Right, so file system directly calls, so that would be, not using threads, or this is the implementation currently chosen by user main. Okay, that's good to know. No single-threaded supports task level concurrency and calculation. Single-threaded does not support task level concurrency. Okay, so you can modify that as well. Evented work in progress experimental. Okay, so this one you shouldn't use unless you're very curious about how it works and you just want to test it. Serving to inform the evolution of the interface. This implementation is based on user space stack switching with work stealing. So new terms for me. Also known as MN threading, green threads, or stackful coroutines. Well, I'm kind of familiar with coroutines. Stackful coroutines. Not sure about that. So it's based on all of these concepts here. IO U-ring or U-ring, or I don't know. Although it was not the focus of this release cycle, there's already a proof of concept implementation based on Linux's excellent IO U-ring API. This backend has really nice properties, but it's not finished yet. It's lacking networking, error handling, test coverage, and minimal task stack allocations. What is it though? Okay, I don't know. KQ, proof of concept only. I mean, I guess we can search for it and see what it is. Okay, sure. IO U-ring, whatever, is a high-performance asynchronous I/O framework for Linux introduced in 5.1, created by designed to bypass the overhead of traditional system calls like EPOL or AIO. It uses shared ring buffers, a submission queue, and a completion queue between user space and kernel to minimize context efficiency. Okay, that's great. KQ, proof of concept only enough to fix a common bug in under async runtimes. Dispatch based on Grand Central Dispatch macOS. Failing simulates a system supporting no operations. Okay. Interesting. So it's like different implementations. I wonder how well they can like work together. Like if you can use one interface with another somehow. I don't know. Maybe I'm just not understanding how everything is supposed to work, but okay, so we have these things here. Future task level abstraction based on functions allows introducing operational independence among any set of function calls. Allows introducing operational independence asynchronously among any set of function calls. Cool. Group efficiently manages many independent tasks, supports awaiting and canceling all tasks in the group together. So kind of like a convenient thing. Many tasks share the same lifetime. They offer O1 overhead for spawning end tasks. That's good. Okay, so here we can see like an example here. We have the IO, testing IO. Initialize an array with 10 random numbers. Okay, I've never seen this. Range implementation, standard random IO source. So you can, what? Okay, so you can initialize an IO, or yeah, and a random instance with an IO instance. Interesting. Okay, so well, okay, they did say that non-determinism was also supposed to be part of IO. This feels very Haskell-y to me. The IO, it's like the IO monad. It has the same kind of feel. It's like everything that is a side effect on the like networking, file system, whatever, and also non-determinism like random numbers and stuff like that. Everything is like encompassed under the I/O umbrella. The difference here is that I/O is just a value that you pass around, while in Haskell is actually a part of the type that you have. But it's the same thing, essentially the same like concept, same idea, same sectioning, I guess, of the. Wait, it has a specific name. Same concern, I guess you could say. Okay, so we're using this to create random numbers. So we just get a random interface here. We create one array with a bunch of random numbers. We sort them. We have a sorted array. We have an index, atomic value, usize in it. So I'm not exactly sure what this does. I mean, it gives you an atomic wrapper around this type. But exactly what is going on, I'm not sure. Spawn a task for each element that sleeps a number of milliseconds equal to the element value, then adds the element. Okay, so we have the group, we defer cancel. So we cancel when we get to the end of the scope. Okay, and then we say we go through the array. We will, so async will spawn a future thing with this, using this IO. Sleep append is this function here. So we're sleeping, we take an atomic thing here, fetch, add monotonic. Okay, so it's just ensuring that this operation is not, I guess, I mean, as far as I understand, it's just to make sure that this thread will run those instructions and not get interrupted by like another thread in this window, so that you avoid. Wait, is that really how it is? If it's shared memory, so you don't end up with some invalid value there, some garbage. Yeah, I don't know. That's my understanding anyway. Okay, so we spawn a bunch of these. So each one will, so we spawn 10 futures. Each one sleeps a little bit. What's the value that we give the element? Oh, spawn a task for each element that sleeps a number of milliseconds equal to the element value, then adds the element. I gotta be honest, like, this type of programming doesn't feel, I mean, I've never seen this in Zig before. So that's why it feels kind of alien here a little bit. But okay. We're doing this. So essentially, this would be like a really easy way to create new threads, right? Like this, sort of like a coroutine call here, right? But you have to be aware of like the shared memory and all that complexity like comes with it. Okay. So we await the group. This would, I guess, await everything inside. And also, like, passing the IO around, it kind of leaves it open to pass whatever IO you have. I mean, of course, you're gonna have to make sure
that it's the same IO. The same IO you pass in here and here, all of them has to be the same, right? So that is potentially a risk. I mean, it's the same for allocators. Like if you use the wrong allocator, if you use one allocator to create something and then another allocator to free it, that's a runtime crash later on. I guess it would be kind of the same thing here, except maybe potentially even more confusing depending on the implementations here. I don't know. Ensure the result is sorted. How do you actually sort this here? What's the algorithm? We go through the array. I see. It's because the value of the element, so we're basically sorting by time. And the index keeps oh, I see. So the index is a shared memory, keeps track of where we are. We're sleeping milliseconds equal to the value itself. This would essentially happen pretty quickly. So it's spawning up all the things, not instantly, but almost. And then these would run in parallel or concurrently, whatever the term is. And so the value with 1 in it will only sleep for 1 millisecond. And so on. So that will be run first. Okay. I've never seen this way of sorting an array. That's actually... Yeah. I mean, it's not really optimal, but it's a really nice way of showing the functionality here. Okay, cool. And then we make sure it's sorted here. Awesome. So I want to test this here. Oops. Okay. Nice. Now what is this, the testing instance? Threaded. Okay. Cool. All right. Q. No link here. Many consumer thread safe runtime configurable buffer size. When buffer is empty, consumers suspend or resume by producers. When buffer is full, producers suspend and are resumed by consumers. When buffer is empty, consumers suspend. I don't understand this, but okay, cool. We got a queue thing. Select executes tasks together. Providing a mechanism to wait until one or more tasks is complete. Similar to batch, but operates at the higher level task abstraction level rather than lower level operation abstraction level. Batch, lower level abstraction based on introducing independence among any set of operations. So what's the difference between like group and batch then and select? Because with group, why not just group the tasks and wait with group instead of using select?
To wait until one or more tasks are complete. Or is this like a race? I mean, you could just have that on the group, right? Operations. Clock duration, timestamp, timeout. Type safety for units of measurement. Okay, cool. And here we have a demo of HTTP request. Cool. Nice that it give you this HTTP example here, because that is also an area that has changed a lot since I started. It's like the HTTP server and stuff. Okay, so we get the arguments. We have a host name, which we take from the first one. We're essentially implementing like some kind of get thing here. Yeah. HTTP client, allocator, and IO. Nice. All right, so we get a request. Usual things here. Except maybe for this one. Percent encoded. I feel like this would be good to have some kind of convenience here. But I don't know. Okay. Send bodiless. Okay. Yeah, and it's gonna use the IO probably to do this. Wait, is this blocking or not? Like, or why were reader writer in 0.15 not 0.16? That changes to them. Which reader writer are we talking about? Because they made like the IO reader and writer. IO dot. So IO dot reader and IO dot writer. These were new in. Was this 0.15? Thank you, Piano. They were new in 0.15, I'm pretty sure. And then they have like the generic reader or whatever it was called. They were basically deprecated. They kept them around because of the transition period. And now they, in 0.16, they removed them, which I think is good because, yeah, it forces people to go over here. Like when they made flushing necessary, yeah. But are you asking why they implemented these first and then IO later? Or the rest later? I don't know. Maybe, I mean, they just divided up the tasks like that. Because 0.15, it also took... I think 0.16 took longer than 0.15. I'm pretty sure. So... I guess it was just to get that out before. I don't know, just the priority of the... But now it feels like IO is kind of... It's more or less complete. It feels like now. Batch. Okay, well, let's take a look at this. You can think of batch as a low-level concurrency mechanism which provides concurrency at an operation level or layer, which is efficient and portable, but more difficult to abstract around, particularly if you need to run some logic in between operations. Okay, I'm just gonna refill my coffee. I'll be right back. Okay, I think what we'll do is I will go. So this is all nice and stuff. I think I'm gonna go deep dive more into this whenever I actually want to start using these things, maybe. And encounter issues with it. I will probably go here and because it's so much information. I feel like what I want to do is I want to go to let's see. I want to because the thing about the vectors is what is interesting to me because I'm using vectors in my game engine. So I want to see, have they made changes that will kind of lower the performance before I decide to, hey, I want to upgrade to 0.16, so that, you know, we don't upgrade and spend a bunch of time on that, and then all of a sudden the game can't run, basically, and that was all for nothing, basically. So I want to just check first. How that works. Entropy. It's a magical word. Okay, so the random stuff is so yeah, okay. So before you could use this built-in crypto thing to get a random instance. So now I guess you just use IO random. That's really nice. Cool. That's actually good to know. Crypto random. And now instead you can do the IO source thing. Yeah. Great. Process. So if I would decide to upgrade Runic to 0.16, this would be something I would have to look at. Doesn't seem to be much of a difference though. Instead of doing this, you just do this. That's fine. Oh, we have to pass IO everywhere now though. It's fine. It's fine. Wait, what's this? Most POSIX are Windows functions existed. An awkward BDN level abstraction has thus been removed. Therefore, if you're using any functions removed from those instances, you must now choose a direction. Go higher, use standard IO. Go lower, use POSIX system directly. Okay, this might also be something. I forget what I used now, but there might be something I used. I forget. Check -- watch. Hang on, I want to say this as well. Incremental compilation. So this, I think this was partially implemented previously. Now it's maybe more implemented. It's a feature of the Zig compiler which allows it to only compile code which has been modified since the previous build, making small changes take milliseconds to build instead of seconds or minutes. Really, really nice. If it works. In Zig 0.16.0, support for this feature has improved significantly. There are some main improvements of this release cycle. Okay, so they've made improvements. Maybe there are edge cases where we can't still use it. I think there was some that it didn't work fully on, like, was it like Windows or something? I don't know. There was something, some kind of caveats or something with this. Now usable both the self-hosted ELF linker and LLVM opting in is usually as simple as running sigbuild f incremental watch. This command will spawn a build process to detect when any source information. Nice. Really cool. Incremental compilation still has bugs, including some miscompilations. Oh man. And therefore remains disabled by default in 0.16. Despite this, we still encourage enabling it.
Users are frequently surprised to just how much time they can save, even with just near instant compile error feedback, let alone near instant compilation. That is actually correct. I mean, I wish it wasn't. It didn't have the bugs. It's gonna be tough to hunt some bug and it ends up being the cause of the incremental compilation. So I'm not sure, but yeah. But yeah, that is a really cool, like, watch and incremental and reading the, like, getting like instant, almost instant like feedback from the compiler. That will be really nice. Error style. Customizing how error messages from build steps are written to standard error. Huh. Okay, right. Yeah. It will be nice when they have it like working without miscompilations. C translation. 6 implementation translation is now based on AROC, and translates instead of libclang. Goodbye and good riddance of our remaining C++ code in the compiler source tree. Huh. Okay. The implementation is compiled. I didn't know they had C++ in there. Implementation is compiled lazily from source the first time C import is encountered. What? I thought they removed C import. I guess it's deprecated. Backed by Oro instead of Clang. Okay. Transition from a library depends on LLVM to a process depends on Clang. This is technically a non-breaking change. Alright. Yeah, okay. Let's see. Does it say anything about the vectors? So, okay. Loop vectorization disabled to work around regression. Loop vectorization disabled. So if you have this in your program, I guess they will complain about it. Loop vectorization. Like what? Can they give us an example? No, this is just LLVM. I want the Zig. Like what does it mean? Loop vectorization. Is it just that you loop? Do they vectorize arrays or only vectors? Incremental building now first class. It's disabled by default. There are still issues with it. There are miscompilations, which would be very bad for me. If you get used to. I don't want to get used to using it, and then all of a sudden I can't use it anymore because there's some weird bug. And then I have to get used to not using it. Go from not using it to, or I mean, go from using it to not using it. That's gonna sting. So I don't actually want to do that. This is more compiler level. Yeah, but it can. It potentially could reduce, because I'm using vectors in my physics engine, so it could reduce like the performance. That's what I'm yeah, okay, I guess we don't see it. If it's not a compiler error, we have to do some like benchmarking if you want to see it. And I can't really just easily I don't think I can easily upgrade the other project. I mean, I guess we could try. Also, is there like a nice way to try to up? Also, like all the libraries. Let's see.
It's still on 0.15. I mean, it might work. Oh. Oh wait, link. Wait, Raylib artifact. Wait. I don't think we need to. Do we need to do this? If we include a module, it should. We don't. I don't think we need to do that. You do like imports. Like this is one of the changes that I'm not too sure about. Like why do we do this instead of the API based way? I would prefer this instead of like creating a config like this. I don't know. Maybe it's just me. Imports, I think it's like a list of imports. See, here the LSP just gives up. Especially if you have a slice of something. Does it so it does understand, once you have it, it understands that this is actually a field in the import thing. And then the module would be Raylib. And here's the same thing. Okay, so could you send something like simply zig run 1 2 3 4 and then some of those? Yeah, I just want to see how easy it is for me to update this, because I'm pretty sure there's not much like file stuff that I'm doing in here. File count is changed to an update. What? Alright, and then we have ztracy, so let's move that up here. We have ECS. Which is added to both these.
Wait, ZG isn't used? Oh, I see. It's the module. It's a okay. I see. This is the exported module. This module is exported to be used by the games. The exe is just an example exe. I remember now. Okay. What is this annoying file constant change during update? Okay, maybe I need to change my setup. And here we go. Here's a whole bunch of compiler errors that we get now from these packages. So they have to update these, or I have to kind of change it, monkey patch this. Indentation has to be something, which is why Linux won't touch Zig. Indentation? Do you mean something else? Indentation, like how many? Indentation has to be something, which is why Linux won't touch Zig. Oh, do you mean like Zig or Linux kernel code base doesn't use indentation? Or what? Never mind, they also use 4 spaces for Rust. Yeah, this is the official formatting for Zig. Like it includes an actual formatter in the compiler or in the Zig project. They use 8 in Z. It's like the Notepad tab. I remember, you know, back when I was using Notepad when I started out programming. And you tab, that's an actual tab character, but it seems like, I think it's like 8 distance from. That's okay. I guess it's a way to try to reduce the line, the actual code in the line, and nesting. Maybe. I don't know. I used to like 2 spaces for a while, but now I think it's too. I think it's too small. It's hard to see the different levels when you use only 2. I think 4 is like a perfect medium for me. Tabs shouldn't exist. I agree. I don't like tabs. Like there's like 2 pros with tabs. It's like it takes, which are very stupid pros, by the way. It takes up less space in the files. That's kind of a stupid pro to me because you know, whatever. And the other pro is that people can decide how much. Like how long is a tab, and that's it. I think that's the end of the pros. I feel like the bad thing that we have right now is that. Well, okay, so the good thing is that now we tackle this issue with different programmers using different styles, is that we force programmers that work together to use a common style, which I think is good. And especially if you have an automatic formatter that you don't even have to think about it. So then you don't really need to care about it. What's the difference, you know? Tabs belong in JavaScript. That's the last time I used them. Well, that's a personal experience for you then. Guess I don't have that. Spaces are more evil when you're not in IDE. What do you mean by that? And when are you not in like a proper text editor?
That's the thing I wanted to get out of NeoVim is like it's very quick to just to open and go into wherever you were last. You don't have to spawn up a whole thing and wait for a bunch of things loading in. Hola, Code Guy. By the way, where are you from? What are we doing? Yeah, okay. So this is we can't do this. Entity has not updated unless they have like a branch or something. No. Is there pull requests, issues, tracking? 0.16. No, I mean I can probably monkey patch this pretty easily. It's probably not that much happening there. The Raylib though. Oh, they're actually updated to well, not the the actual 0.16, but they have actually updated it. So probably just updating this would be enough. Let's try it. So we go into the zone file and we copy this part. Actually, I think you need to save it as well, I'm pretty sure. Okay, there we go. And now, do we have any? I think we need to build it as well to get it. Okay, that got rid of a whole bunch of troubles. We have ztracy, which I'm not confident. I mean, even now it's like on 0.14. So, I'm not confident that... But I can just disable ztracy. It's just for profiling. So, we can just actually... Well, we don't even need to... Where is it? Wait. Okay, we still get the error. So I guess we'll get rid of that. Okay, cool. Now the only thing left is the entity package. And I guess we could clone it. So what you can do is you clone the thing. And then you monkey patch it. Wait, what? Did they update it to work or? I'm confused. Okay, let's just update it, I guess. Then. Oops. Okay. Wait. Don't take it out. Okay. Build. Okay, there we go. Oh man, I have to. Do I just try to create a stub for that? Just because I don't want to go in and do a whole bunch of... It's basically used everywhere. So I would have to go in and disable a whole bunch of stuff. Let's just do... module, create module. Source file is... Why the screen is brighter today? It's not from my end, I don't think. I'm from Imaginosia. How are you seeing the errors list? Is that a built-in? That is... I think it's built-in into Zinc. Diagnostics. It's like... well, I think I'm using like a telescope. I think. This is a telescope view of the diagnostics that is like all the current diagnostics reported to Neovim right now. So I've just bound it to leader EL. So error list. You made... I added a teleport command to my voxel game. It crashes if you teleport too far. Cool. Why do you think that is? I made another PR to Rust and the reviewer never said anything. How long have you waited? An unassigned reviewer suggested some stuff, but the flag is still on waiting on review. You should really update Neovim. Never. Wait, why do you say that? Why do you say that I should update Neovim? Let's see. C-Tracy. Yeah, so we create the module. Is there anything else we want to set on here? I'm not sure. Code model. What the hell is that? Dwarf format? I'm not sure. Did they have dwarf? I thought they talked about this at some point. Error tracing, fuzz, imports. No. Okay, nah. There's probably nothing we need to do there. So there we go. So now we got the Z-Tracy module, and let's just enable that over here. So now that should be available. However, it should be available now. Let's restart the LSP, I guess. There we go. And zone context. Probably another one of these structs.
zonen. Oops. Actually, that's a function. Function takes label, I guess. Wait. No, that's the source. Source. I don't know where this lives. Source location, maybe. Yeah, that seems to be correct. And then the label gives us, I don't know what it gives us, a zone context. Okay. Standard. Wait, what? Root source file struct heap has no member named general purpose allocator. 3 weeks. New updates are probably cool. I didn't check the changelog. Yeah, I mean, I feel like, oh yeah, you waited 3 weeks. Okay, yeah, that's a long time. You should probably bump something to, maybe they forgot to press the submit review button or something. Yeah, I mean, regarding the NeoVim update, I'll probably do it at some point. I just don't feel the need to do it, you know? I feel like I can still use the editor as it is right now. I don't really feel the need to update it. Why are there, because it also, like, if it was easy, I would do it probably more keenly, but it's probably gonna be a lot of breaking changes that I need to fix, and I don't really want to do that, so that's why I don't want to update it right now. Why are their built-in name the same as built-in function? Why are their built-in name the same as built-in function? All right, Boracek, you do that. Why are they built-in named the same as built-in function? Which one do you mean, Ian? Standard and the at. The standard and the at. That sounds like some kind of book title or something. No, this says source. This says SRC. Or do you mean that the standard has a built-in? This has a built-in here. It's just a place to put something. I don't know. I don't like. Yeah, I can't explain why it's put in here. I think this is used for maybe like internal, like compiler stuff in here. There's like type and source again. So it's kind of random to me. It's like, I don't know. What's one thing that's bad about this source thing is that you can see this return type. So you can actually take this string, go into the Zig's documentation or standard library documentation, search for the string, and you will find where it is. But you can't actually go to the type definition of this. If you do this, okay, this does have a source location. Okay, so you can do this as well. However, you can't. I don't think you can get like it's very bad with the auto completion for this, and also the type information from this call doesn't work. You have to do this. Now you get these things. That's also bad. But yeah. It's not like a huge deal, but it's a little bit, you know. Okay, so what is it complaining about here? Root source. Also, we need to implement this end function. It's just a function end. There we go. There's probably some other function we need as well. Now, instead of creating our own general purpose allocator, we can actually take the init thing here, which I forget where it is. Juicy main? No. Was it built in? Man, okay. This is something that's gonna be living in my head probably at some point. Oh, it's standard process init. Okay, that kind of makes sense, yeah. Okay, so we got the init, the GPA we don't need to grab out like this. I'm not even sure we need to call dinit on it, since we get it from out here. It's probably gonna be the initialized. A default selected general purpose allocator for temporary heap allocations. Debug mode will be set up for leak checking if possible, thread safe. Okay, I'm just gonna assume that they are deinitializing it from outside main. Hopefully. Juicy main. Is that something they say here? Well, they're not deinitializing here, so I guess they are. Cool. Also, min-max accept more orgs. Really? No, I think this was from before. I think this already. I think this is an earlier change. I'm pretty sure they had this already, if I'm not misremembering. That they could potentially have more than 2 arguments. That might have been earlier. I don't know, but it's good that it has it there now. Okay, so our allocator is init GPA allocator. Wait, no, this is the actual allocator. Okay, so we don't even get the GPA struct thing. But we still want to do dot allocator. Wait, no, GPA. There we go. Cool. Okay, what else is wrong here? Okay, let's do that. That's an easy fix. And auto rehash map. What? What do you mean? Migration to unmanaged containers. In the past, SIG library, standard library offered 2 variants of dynamically growing data structures. One with the allocator instance as a field of the structure, unmanaged, where it must be passed into every method that it needs it. Unmanaged. Over time, SIG programs realized together that the variant without allocator field is more versatile, and the other one should be removed. With only one variant, we no longer need this vague word managed to distinguish them. In this release, several APIs took migratory steps. Array hash map, auto array hash map, and string array hash map removed. Added memory pool unmanaged. So, wait, what? So they added unmanaged versions.
Oh, I see. So now they live in array. They don't live in like standard like std dot. They live in std dot array hashmap dot auto. Okay, I like that change because it was always strange that it was straight up in the S standard module. Okay, so we simply have to use this one instead now. This is gonna maybe cause some issues, or not issues, but a lot of changes needed. I mean, I usually use the unmanaged versions because it felt like that was the managed versions were getting deprecated. So I know that there was one library that actually used a lot of managed. Was it the entity library actually? Yeah, we'll see. We'll see. Maybe they changed it around. Still unusual for Zig. Yeah, normal functions in Zig, you cannot actually define a function that has variadic parameters. So the only way to do it, there's one kind of workaround, and that is to use a C function. You define a C function with a variadic parameters, and then import that into Zig. Then you can have a variadic function, but not in Zig. You can't define a variadic function in Zig, a Zig function. Actually, how do you define a variadic function in C? I'm pretty sure you can. Yeah, you just have dot dot dot. Okay. So, but the built-in functions, the at, min, at, max, those are special, so they can have. Okay, I see. It's still kind of strange that it lives like straight. Like I would expect this to live in like standard.data or something like that, and then have like a bunch of data structs instead of having them directly in here. Like I understand that it's so commonly used, so but still we still have these things like straight up in here. So why is this still here? Okay, so this would be auto. No, there we go. And string array, I guess. String. Yeah, the min and max does have the dot 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 here. But this you can't define a function in Zig for this. It only works with the built-in functions. But I said that technically you can define a variadic function in C and then import that into Zig. So then you can kinda have a variadic function in Zig. As long as you import it. This one is also array hashmap auto, but it doesn't require. It doesn't take an allocate. Wait. No, this is different. This is supposed to be empty. And this one would require an allocator. Actually, we could, instead of, yeah, we could store the allocator here, I guess. But again, it depends on how this is used. I don't even remember this, to be honest.
Okay, let's do it like this. I mean, essentially it's just a wrapper here that doesn't really do anything, but here we have to pass the allocator, I'm pretty sure, yeah. Okay. Interesting, the type changed a lot here. Custom entity class, what is going on here? Entity class. Oh, entity class is the, sorry, that's from the library, right. Oh, why is it just a function? That's weird. Okay, anyway. There we go. A lot of these changes. Array, hash map, auto. Empty. Actually, we don't even need this here. We don't need to specify the type anymore. Oops. There we go. Oh yeah, also we don't need this. We can provide an empty. Same thing here. Oh wait, but you are string hash map. Let's just change you to unmanaged as well, so we don't run into this issue again. And we don't need this. I mean, we could just remove this. Initialize. Wait. Yeah. Yeah, that's correct. Get or put. You need an allocator now. So yeah, let's just use that. I mean, we already pass allocators in here, so all right. And this is IO file now instead. Oh yeah, so here right, we saw that we could do this instead. File.writer and then .init. I mean, it's not really that much of a difference here, but and it's just IO with a buffer. The IO is from up here. There we go. And that's not my problem. Okay. Oh yeah, we need to add self this for this to work as a member function, and it's unused.
There we go. Vector index not contain on. Oh, okay. Let's fix the rest first. Oh yeah, that's right. Oh man, this still doesn't work. Okay, so that's why that was like it. But this one does work. We can move that one. Z-Tracy has no member named. So we have NC, so we have source, label, and then I guess this was the color, U32. There we go. Okay, so the only thing left is this, which I'm not sure how to fix. I'm gonna check one thing first, like, are we even using these? I think we are. Perhaps, yeah, we are. Maybe, actually. Yeah. Or yes, we are. Okay. So how vector index not com time no. So do we have to convert it to an array? Is that the thing now? We have to convert it to an array. So if we look at what this type is, well, it's okay, it's T, but it's a vector. Which is this, it's just a vector. Right, so this is a vector, right? Or is it? No. Wait. There we go, that's the vector. Okay. And then how did they do it? Vector something something pointer. So you can't like access a vector index directly. We have to coerce it to an array and then access it. So they did this. We have the vector type. We don't need that. So this will be vector length. Wait. No, that's the type info. Right, type info. Oh. So
Okay, vector type is type info vector vector. There we go. So this would be vector type dot length. I was checking if there was like a convenient way to do that, and then this would be v. Oops, and this is the array, and then instead of doing this, we will do that. No, array. There we go. What? But in the example, they use const. Because if I change it to var, it's like it feels like, okay, you're creating a copy. No, we don't create. We're creating. I don't know. This is weird. I guess we can try to see if it works. Set A is also okay. So then we do that is equal to value. Oops. This feels very strange to do it like this, but I'm just mimicking what they are doing. Kind of like when they loop through the array, they use like this and get the element out. So now I don't know, man. I guess we can just try that. Okay, it seems to have been upgraded now. So let's run. Not sure if you can see. Whoops. Okay, we got some errors. Okay, so Raylib actually started up. Starting the thing. Panic index out of bounds. Okay, let me check. Let's see, I need to add more things to git ignore. Okay. We got a whole bunch of collision events. My first thought is that did I change this so that we spawn a lot more than we used to? The scene. One player, one rectangle. Or did I just update the system? Okay. What the hell is going on? I mean, okay. It might have something to do with the actual things we did in here. So the job of this function is to essentially provide a pointer into the vector where this body exists. So each thing has a rigid body, and we have a position, velocity, acceleration. All of these are, it says here, p vectors, which means they are pointer. They point to their respective values, which then live in this vector list here. So I'm not sure what's going on with this array conversion here. If we can actually get the vector address properly here. Like before, we just needed to do this. But that doesn't work. Vector index not comp time known. Seriously. I found this one. Design for simply vectors and indexable in an inconsistent way. I'm not sure if this is what we're dealing with. It's closed, so in the end, someone closed it as completed. The index is scalar, indexes elements. If the index is a vector, it can perform an array element access or struct field access. What? Welcome back, Penguin. See in Codeberg Yeah, I mean, this was a long time ago. It's closed. I'm not sure what's going on here, but I just want to know how to fix this issue. Like, how do I actually do it? How to index, because this seems to be a new error. It's just forbidden. And this doesn't work. Like, I want to get the actual address into the vector, not copy the thing or whatever we're doing here. I don't even know what's going on here. They close a lot of issues to Codeberg. Yeah. They moved the migration there. Yeah. So it's just forbidden, like you cannot index into the vector. So does this just just doesn't work? I have to kind of I have to rebuild this in a different way. Okay, so what is happening? So this is essentially, it is only kind of used in one place, I think. Which is these functions. They are essentially only used. Well, they are used in these two functions. So get rigid bodies, but this is only used when creating a new rigid body here. So and the thing is, like, we set yeah, and then this is also the same problem here. So how would you actually do this then? Like, I just want to know, like, what actually happens when you coerce. Okay, so let's do a test here. Oops. We'll create the vector type. Let's just do like 2f32, whatever. Okay, that's our vector type. We'll create a vector of this type with elements something something. Okay, we can log this out, and then if we just zig run we get this thing, okay? Now, we can't actually do this then. That is, as far as I understand, or wait, it's comp time known, so now we can do that, okay. But what we can't do is loop through I mean, we could just do this and use I. So this is not possible, as far as I can tell. Or is it possible? It's apparently it is possible. What the hell? Is it unrolling this loop, or what if we use wait, what? Buffer. Does it fill buffer with random stuff? Or where was the random thing? I forgot what it was called now. IO. No, wait, it was random and then IO source. There we go. Wait. There we go. There's our random. And now we do random. Well, we do like length is gonna be random. Okay, so I guess this could be a const. And then uint less than 2. Why can't I get like the length of the vector? Or can I get the length now? What the hell? Let's do like times 10 or times 5, and then this would be mod L, no, mod wait, so why does it work now? Why are you discarding the argument? Which argument? Isn't this... Now this is not comp time known, right? I was discarding it because if a variable or if a binding is not used, you have to discard it. Otherwise, the compiler won't give you your executable. It's a compiler error. But now I am using it. I'm using it here with init. Why does this work and not the other one? I mean, this is comp time known, so yeah, the length is comp time known, of course. It has to be. Apparently, this is not comp time known. Vector index is not comp time known. Is it because the vector is not comp time known? This is comp time known. The vector itself is comp time known. What if we have a mutable vector that we fill with random numbers? Okay, there we go. Wait. Okay, so if the vector is comp time known, this works. But if it's not comp time known, I mean, yeah, I guess that makes sense. So now it's not comp time known. We fill it with random numbers. It's runtime known now. Now it says vector index is not comp time known. Because otherwise, before it was comp time land. Now it's not. Okay. Can you fix this? Is this fixable somehow? Also, what I wanted to test was that if we made an array that is, you know, length and F32s, and we do array I instead, I mean, this, it's never mutated. And we can't pointer cast. We can. Yeah, why disallowed us? It was something to do with some kind of I don't know, some kind of internal issues with the IR, I think. So how? So okay. So if we get rid of this, and we just try to, I just want to log out the vector now. Can we even do that? Is that even possible? Yes, it is. So you can see that it does change the vector. So you can create a but this doesn't need to be var though. But yeah, interesting that it didn't complain about that. So you can create a pointer that has the array shape, that has the same kind of shape as the vector, pointer cast, and then you can manipulate. Also, how is this even doing? How are you doing this? I don't know, man. I couldn't get this to work, but yeah. Okay, let's go back. So we might have a way forward here. Where were we? Here. Right. So we'll create the array is a pointer to the vector. No, sorry. It's a pointer with, so we'll do vector type is type info vector, and then this is type length. All right, I have to go here soon. 1 second. I just need to finish this here. This is this. Oops. And then we return array. This, right? Forecast. I don't know. It's probably, you probably should follow how they are doing it, but and then over here. I'm gonna do array. Wait. Oh, we just did this actually. I just did this. That still worked. I guess it auto dereferenced it or something. maybe. Okay, there we go. And I can add a whole bunch of these. And we have the physics simulation working again. Woo! Okay, so great. And what's good is also we just needed to update all the libraries. So essentially we could upgrade we could upgrade our other projects to this here. But yeah, cool. Ice hockey, yeah. It's just a little example to test that the engine still works and all that. Let's try this. I want to enable the thing. This part here. So now it will add a bunch of bodies until we start to like see the FPS drop. So this was how many we have right now. So I'm not sure if this was more or less we had last time, but I mean it's not really that impressive to be honest. But again, this is my own like physics engine, so it's not like state of the art or anything like that. It's just a fun project really, but it does fulfill its purpose with making my game. So there you go. And here's the quad tree visualization as well, where you can see all the different quadrants everywhere that are dynamically created here. But yeah, I have to go now, but that's gonna be it for this time. So thank you very much for joining me, and I'll probably continue next with tackling my Metroidvania game. So we'll see how that goes. All right.